you that are joining us the first time, we will put all the recordings up on the Pragmatic Works site, hopefully by the end of today. And there's over 100 recordings there now for various sessions from the past, so that's good. The question here is, what's more important to you with SSIS? Development, deployment, production monitoring and auditing, or documentation? And I would imagine it's probably, I'm going to guess what I think the answer to this is going to be. And I guessed right. All right, over 80% have gone ahead there. I'll go ahead and close that poll out, share it with everybody. Looks like, of course, all of you are mostly consider yourself development around SSIS, so of course development and ease of development and efficiency would be best for everybody. I'll go ahead and close that out, hide that. And Jose, I'll make you presenter real quick.
All right.
I'll stay on the line with you until we can see your screen. And of course, we're going to follow our normal format here too. Jose will go through his session, and towards the end of the session, we'll open up for Q&A. We'll hopefully get through to everybody's questions. And Jose, I can, there you go. I can see your screen. It's all you.
All right, excellent. So, all right, so welcome everybody. My name is Jose Chinchilla, and I'm going to be your presenter today. And I'll present Zero to SSIS, which is a quick intro to SSIS, and we're going to overview some of the common T-SQL tasks that you are familiarized with in writing code, and we're going to see the corresponding SSIS tasks and transformations where you can accomplish similar results as with your T-SQL skills. So my name again, Jose Chinchilla. I'm a micro-certified database administrator and business intelligence developer. I work as a consultant for Pragmatic Works, and I'm also the Tampa Bay Business Intelligence User Group leader. You can reach me through Twitter. I go by the handle name SQL Joe, and also by email and LinkedIn. And I like to blog on sqljoe.com and also at bidn.com. So you'll see some blog posts in there. So today's agenda, we're going to cover some terms and acronyms. We're going to do a quick overview of the development environment for integration services in SQL Server 2008 R2. Some of the common T-SQL to SSIS tasks, and the corresponding SSIS task where you can accomplish the same T-SQL commands or tasks that you're familiar with. And we're going to do a quick demo on Business Intelligence Development Studio, some of the data sources, data source views, what different packages that I have created for you, some of the control and data flow tasks and containers and transformations. You're going to see some of the different sources and destinations available in SSIS. And we're going to do a quick overview also of some of the variables and scripting in SSIS. So first things first. There's an extensive list of terms and acronyms that I put together, but the most important ones that we want to focus today are this package, container, task, and transformation. So some of you may already know a package is an XML file which contains all the business logic and workflows to process data, extract data from a source and dump it into a destination. And in between, you will do some transformations. A container is just an object to group tasks. A task is a component that performs a specific operation, such as an update or transform the data from data type to another data type. A transformation, you will modify and manipulate that data. And also, I want to point out to what BIDS stands for, because some of you will hear that term, BIDS, and that's a Business Intelligence Development Studio, which is a Visual Studio shell with the specific tasks and information needed to perform some of the ETL and some of the other transformations in SSIS. So what is SSIS? SSIS stands for SQL Server Integration Services. It is a platform for data integration and workflow applications. It is commonly used for the ETL process, which stands for extract, transform, and load. But there's a variant to that, and that is the ELT, which is the extract, load, and then transform. Both of them can be achieved with SSIS. You can do DML operations. These are data manipulation language, which are the inserts, updates, and deletes. And you can also do DDL operations, which are the data definition language, which define objects in your SQL Server instances, like a create or drop a table. You can use it to automate maintenance and other tasks for SQL Server database administration, as well as OLAP cubes and databases in SSIS. So SSIS is considered the jack of all trades. It can be used to carry out many tasks. You can export data, you can run Visual Basic and C# scripts, you can insert, load, delete, update data, you can extract, cast, convert data, you can do aggregations, you can do file system tasks such as copy, delete, move, create folder, delete folder. You can do, new in 2008, you can do a data profiling, which is very useful for your ETL data warehousing. You can read and write through the Windows Management Instrumentation, which is the WMI, and you can derive and calculate columns with SSIS. So at a glance, these are different languages or different ways SSIS interacts with sources and destinations. So it is regularly used for OLTP and OLAP. You can do T-SQL. You can even do some DMX and MDX inside SSIS. You can also you can use it to read XML and output to XML. You can write, as I mentioned, you can read and write to the WMI. You can do file network operations, C# and Visual Basic scripting. You can also call web services through SSIS and your regular ETL or ELT, right? These are some of the groupings that, some of the task groupings that I put together, so you understand what are the different options available under control flow and data flow. Basically, you can group your control flow tasks by these 9 different groups, and your data flow can be grouped by source and destination transformations. So this is just a general grouping of what you can, how you can group all your tasks between control flow and data flow. So are we going to cover all of the tasks and transformations in SSIS in about an hour? Of course not, right? So we're going to just focus on some of the most important ones that you are going to need for your day-to-day operations and to carry out some of your tasks. So first of all, the development environment. As I mentioned, SSIS packages can be developed through Business Intelligence Development Studio, which is a Visual Studio shell. It's a subset of what Visual Studio can do and just has all the Business Intelligence and SSIS containers and transformations. As you may know, also BIDS came with SQL Server 2005, 2008, 2008 R2, and will also be there for Denali. You can run Business Intelligence Development Studio under Windows. You can use XP, Service Pack 3 is the minimum requirement. You can run it under Vista, Windows 7, but most commonly you'll see it running under a development server, like 2003 all the way to 2008 R2. And that's a link where you can go to see the minimum requirements for all the different operating systems. SQL Server Integration Services comes bundled in the Standard, Enterprise, and Developer Edition. Other specialized editions like SQL Server Workgroup Edition does not come with integration services. And you'll see a chart that it compares all the different editions. So if you don't have a SQL Server license, SQL Server 2008 license, you can download a copy, a 180-day trial from Microsoft website, or you can buy your own license for about $50. And Amazon, for example, had this one for $49.99, and it's a SQL Server 2008 Developer Edition. It's a single user, and it is full-featured for development and testing. It's not intended for production, and the important thing to know is that the Developer Edition has all the Enterprise Edition features. So it is an Enterprise Edition license, but you cannot use it for production. So it's just meant for developing and testing and getting to know the technology. So $50 and you have the full feature SQL Server 2008 R2 Developer Edition. So there's a quick comparison between SQL Server 2008 editions, which is the same for R2. If you see Enterprise has a couple more destinations, adapter transformations than standard. And if you see Workgroup, Web, and Express, which is some of the specialized editions I talked about, they don't come bundled with SSIS. So if you want SSIS, the minimum you want is standard edition. But of course, you can get Enterprise or the Developer Edition and have all the features available for you. So from T-SQL to SSIS. So these are some of the basic tasks that you would normally do with T-SQL and the corresponding SSIS task or transformation. So first of all, you can do updates, which are the set-based updates. You will do it in the control flow, execute SQL task. You can also execute stored procedures there. You can do loops, like for example in T-SQL, the while command. You will do it in the for loop or in the for each container. And there's a slight difference between both of these, and I'll show the difference. You can do file operations, copy, delete, move, files, directories. You can accomplish this in SSIS control flow, file system task. You can send mail, use the send mail task. You can bulk insert, using the bulk insert task, right? So some of these usual or regular T-SQL statements, you can accomplish them with some of these existing SSIS tasks. In the data flow side, some of the other T-SQL tasks you will do is like, for example, a select. That corresponds to a data flow source. An insert, that will be a data flow destination. An update, which is a row by agonizing row, will be an OLEDB command. If you want to do a case statement, you would normally use a conditional split. If you want to convert or cast, you would do a data conversion. You can do an if statement using a derived column as well. You can do some math, date, string, aggregate, concatenations, and casting operation also with derived column. You can do merge with a corresponding merge statement, and you can do joins, left, right, and full outer using the merge join. You can order by using a sort transformation. You can union, do a union using a union all. And you can do your aggregations, your regular group bys, count, some averages using an aggregate data flow. And I'll show most of these examples. And for that, and now we're going to go to our demo. So let me jump right over here. And first of all, let me describe what I'm going to be using as a source and destination. So first of all, I'm going to be using the AdventureWorks database. You can see there's a big list of tables. But for today's demo, today's presentation, I'm going to use the work order routing, and scrap reason table. So these three tables. And just for a quick explanation what the work order is a table where the AdventureWorks company, which is a bike manufacturing company, has a record of all the work orders, what products went into each work order, what was the quantity ordered, what was the quantity scrapped, meaning if there were any defects or any production issues, and for some reason that product was bent, broken, damaged, it will be sent out to the scrap count quantity. If there was no scrap, then it will go all to stock quantity. So from order to stock, and the difference will be ordered minus scrap equals stock quantity. If there was a scrap quantity, there will be a scrap reason ID. In this case, there's 0 scrap, so there's no scrap reason. For some others, you'll see there's 4 scrap products in this work order, and there will be, and this will be because of reason ID 14. And if we go to the scrap reason, you'll see the list of scrap reasons. So for scrap reason ID 14, that will correspond to the trim length too long, right? Now, if you see some of these scrap reason descriptions, some of these are very similar. So as part of my demo, I will base the requirements on my packages based on this table, in which a business manager or a production manager might ask us, okay, I don't want the detail of drill pattern, drill size too small, drill size too large. I just want to group anything that's 4, 5, and 6 into a general scrap reason group called drill issues. Same as paint, anything that has to do with paint, I just want it as a paint process issue. If it's a damage or any other issues, then group it as correspondingly. So from these 16 different scrap reason IDs, I derived, I believe, 5 or 6 group reasons, and I'll show that in a little while. And then the other one will be the work order routing, which I'll explain in my example 3 or 4. So let's stick with product scrap reason and our product work order. All my output, this is my source table, my source database, and my source tables, and I have a destination table with some destination database with some destination tables. So in this case, I have scrap category totals and some other that I'll use in some of my examples. So the first thing will be explain the bits environment. So when you create a new SSIS project, you will go to File, New Project, and select an Integration Services project. You'll give it a name, a location. You can decide to create a new solution, or if you have an existing solution open, you can add that project to the existing solution, and then you can give the solution a name. In this case, I have already created one called the SSIS AW samples. AW stands for Emergency Works. And when you create a package, this is the basic construct or the basic structure that you'll see. Data sources, data source views, packages, and some miscellaneous. So data sources, this is where you're going to define your connection strings to your different source and destination databases. So in this case, I have a AdventureWorks connection string, which points to my local host. In real world or production environments, you want to avoid writing localhost. You want to write your actual server name. And then you'll select the database on that host. Connection succeeded, so I am good with my source. And I'll do the same for my destination. Again, you want to avoid localhost. You want to write the actual name or IP address of your server. And I'll select my database that I want to work with, which in this case the AW samples. All right, so I have my 2 data sources, and these are shared data sources. So anything I have in this project, I will be able to point to these data sources as a shared data source. Now I'll explain how that looks. You're going to have data source views, which is basically just a subset of your data source. So if your data source, your database, for example, has hundreds or even thousands of tables, and you want to only work with a couple of them, then it will make sense just to limit that data source view to those couple of tables that you want to see. Or if you want to alias some of those tables or alias some of those columns, or even do some aggregation or some changes to the table structures, then you'll do it there. But in most cases, you'll go directly to your data source. Next, you will see a list of all your SSIS packages, and we go through each one of them. And at the end, you have some miscellaneous. So in this miscellaneous, you will see you can have scripts, you can have documentation, you can have images, diagrams. So whatever you want to put here, it's just a placeholder for anything that's related to this solution or this project. So in this case, I have a script that I'm going to use at the end to show some of the results for one of my packages. So what I want to do now is I'm going to open my first package that I already created. And this one is to exemplify the many possibilities, the many options, or the flexibility of SSIS, in which you can have one source and one destination. So one source, one destination. You can have one source to many destinations. You can have many sources to many destinations, and so forth. And in between, I'll show some other merge options here. So first of all, we're going to enable this control flow task, which is a data flow task, which is just a grouping of all my data flow tasks in the backend. So the first thing I'm going to do is execute this truncate table. And that truncate table is essentially an execute SQL task. And in that execute SQL task, I have defined that my connections will be my destination connection, which is down here. And I also define what is the SQL statement that I want to run here. So in this case, I'm truncating the table year 2003 Q4 customers in my destination. Something to point out is that I have all these connection managers here. And for example, only the B source is just simply pointing to my shared SSIS AdventureWorks data source. That's one of my destination. These are just pointer connections that point to the corresponding data source up here. So in this way, you don't have to create a connection manager for each, saving you on some, in the back end with the SQL Server, some of those connections, you can reutilize those connections by having shared connection managers here pointing to your shared data sources. So this is what I have here. So truncate table with my destination year 2003 Q4 customers. Once that completes, I'll go into my first example, which is the data flow task for one source to one destination. So this is a very simple one, and essentially you have a source. In this case, my source is based on a SQL command. You can have a table view or a name variable or a SQL command from a variable. In this case, I chose to write my own SQL statement. In the SQL statement, I'm selecting from the AdventureWorks sales order header, and only selecting those order dates that fall between October 1st and December 31st. I can preview that statement, and I have data coming in. If you notice here, I have all these columns that I'm selecting. I'm actually deriving this one. And if you see on your columns pane, you'll see the list of columns that you brought in your select statement here. I can choose to select them all or deselect a couple that I don't want. But in this case, I'm interested in all the columns that I brought in. And I have the chance here to change the alias name. So instead of having a customer ID, I can have customer code or change it to whatever I want. So I can alias the column names here as well. And then I have a destination. And my destination, of course, is pointing to my OLEDB destination, which is this connection manager down here, which in turn is pointing to my SSIS AW samples data source. Once I define my OLEDB destination, I choose my destination table. In this case, will be the year 2003 Q4 customers. And if my source columns match the destination columns, SSIS will automatically map them. If not, you will have something like ignore next to a destination column, and all what you will do is select salesperson ID or drag salesperson ID to salesperson ID. So now this mapping is created. So I'm going to run that package. And I got from my source 5,140 rows into my destination. So I'm going to stop this. I'm going to do a select statement. So that's the result so for my source to destination. I'll do a quick count. And I should have 5,140. So we are good. Now, if you see here, I have a truncate table at the beginning. And the reason I'm doing that is because I have a primary key constraint on sales order ID. So I cannot repeat my sales order ID in this table. I cannot insert duplicate sales order IDs. So if I disable this truncate table statement, SQL statement, and I try to rerun it, I will get an error. And there's my error. So as you see, green means good, everything flowed correctly. Yellow will mean it is in the process of executing, and red will mean something failed. So when something fails, you have several options. You can check here in the progress tab where the error happened and what happened. So you can see everything looks good up to here where you have these exclamation marks. You can copy the message on a notepad and try to figure out what was the error. So in this message, it's telling us that we have this error code, and then another error code here with the description, violation of primary key constraint, cannot insert duplicate key. So right there it's telling us that we had an error because we were trying to insert a duplicate key in this table, which is not allowed. So now that we know that, we have several ways of dealing with errors. One easy way will be creating a output, outputting all those error rows or rows that did not make it to my destination into, for example, a flat file destination. So a flat file destination is essentially a comma separated value or a text file. And you will specify here that you want to redirect rows on error. So if you go back to this OLEDB destination, and you go to error output, by default, the default behavior is to fail the component, which is what happened a couple of seconds ago. There was an error and the whole operation failed. So if you want to redirect those failed rows, what you will do is you will choose redirect error and drag this error destination, this error path, to my flat file, and it's sensing that already that I have chosen redirect row. And all the errors that errored or did not made it to the destination will be sent to this flat file. So in this flat file, same as the other destinations, you have to define your connection manager. So I already have a connection manager called insert errors, which is this one down here. And I'm going to map the different columns that I want to be sent to that file so that I can check, what was the issue. So if I run this, although the rows did not make it to the destination, to my table, no error happened because all those errored rows were sent out to this flat file. An example, if you go to insert errors, which is my connection manager for that text file, it's basically just pointing to a file in my file system, and you can define how you want that file to be constructed. In this case, I want it delimited by a comma delimited file. If we go and see that and view that file, we'll see the output of everything we just sent right now in that error output path. So in this way, you could see, for example, okay, what was the issue? What was this value? Why this group of values didn't make it into my table? And it can be useful for auditing and troubleshooting. So that's one way of doing it. The other way is just just ignoring the errors. So if you don't care about the errors, you just select ignore failure. And everything will look as if everything ran fine. But sometimes that's not the intended behavior. We just don't want to ignore errors, right? So let's change it back to fail component, which is the default. And something really nice about SSIS is that it includes the event handlers. So event handler, as the name describes, it's a way of handling certain events in your package. So in this one, I created one, which is called one for the event, one source, one destination. So I can be granular as to where I will handle errors. So if an error happens at this stage in my data flow task, one source to one destination, then I can choose what error I want to handle. In this case, I want to handle an error. So upon any error that happens in this stage, I want this set of tasks to execute. In this case, I just have a simple notify operator task. So if you see under your maintenance plan task, you have your notify operator task. So this notify operator task, what we'll do is it will connect to a database mail profile and notify certain operators defined under your database mail. So if I go back to my SQL Server instance, I have under management database mail, which is configured, and under SQL Server agent, I have this operator, which is myself, Jose Chinchilla, with the email address I wanted to send all notifications to. So you need database mail to be enabled, and you need SQL Server agent to be running for database mail and notify operators to work. So I have that defined here. So anytime there's an error, it will send me an email. It will send an email to this operator with this subject, and it will, in the body, it will send this text. If you see here, this is just a kind of like a static text. But in reality, what I'm doing here, if I go to my properties, under expressions, so each task has what's called expressions, and you can manipulate different properties of that task or container through these expressions. So if I open expressions, I have a couple of properties I can choose from. In this case, I'm interested in the message property, and you can build a dynamic expression that will you can fill that expression for that specific property using whatever dynamic expression you set here. You have a couple of variables which are system variables, and these are very useful. For example, in here, what I'm doing is concatenating this string. This will show us error code plus the system code, the system error code that was generated, converting it to a string. So error code X was generated while executing package, and then I'll extract the package name. So you see a system package name here. The error occurred at, so I have a system event handler start time. So this is the time, specific time where the error occurred. So this is a date time, so I'll convert it to a string. So the error occurred at this date and time on server, and I have a system variable called system machine name, which will be your server name. In this case, it's my laptop's name. And then the error description is, and you have that system error description variable there. So since I had a couple of errors, I should have received a couple of emails with those errors. So if I go to my Gmail account, I will see a couple of email messages that came through. So if you see here, I got 1, 2, 3 errors. And why 3? Because if you go to our execution results, when we errored, we caused that error, you saw 3 different errors happening. So it will send 1 email per error. So in this case, this is the dynamic text that was generated. Error code what's generated will execute in package, and this is the name minus the parentheses because it didn't detect those parentheses. So the error occurred at date and time on server, my laptop, the error description, the big text here. So you can dynamically send yourself an email or do a put all those errors into a auditing table, a log table, using these event handlers. So those are very useful when you have errors. Another, let me change this to, okay, fail component. Another good, something I want to point out here also is what's called data viewers. So if you click on this presence containers, you'll see that there's an option called data viewers. So data viewers, as the name itself describes, is a way of viewing the data that's flowing through that data flow path in that specific point in time. So if you want to debug and say, okay, why is it failing? You can put a data viewer, and you can see how your data is coming through as it flows through this data flow path. So you can browse to the different data set and figure out why is it failing. So you can grab, for example, a sales order ID and say, okay, what, and do a select statement here on your destination table and check if that data source, if that work order exists on your destination table. And then you'll figure out, oh, okay, I cannot insert duplicate.
Jose, it's Tim. I don't know if you can hear me okay?
1 second.
Okay. I think you might have hit mute. I apologize. You've been out for about 15 seconds.
Oh, really?
Okay, there you go. Okay.
Okay. All right. So sorry about that. So what I was explaining here is that you can add data viewers if you didn't catch that. And a data viewer is essentially a way of viewing the data that's flowing through this data flow path. You can also, under the data flow path, you see this edit option, and you can see the metadata, and you'll see the data type that SSIS is detecting as the columns are coming through. And this is very important because sometimes you'll find data type mismatch errors, and you want to figure out why is that mismatch. And you were expecting customer ID to be a 4-byte signed integer, and SSIS for some reason, and depending on the driver, you'll see that it's maybe viewing that customer ID as a small int or as a big int or as a decimal numeric. So this is very important when troubleshooting and debugging SSIS packages. All right, so that is our quick example of one source to one destination. So my second example is one source to many destinations. So this is the same example, but in this case, I'm using a transformation called the Multicast, which you can find here, Multicast. So Multicast, as the word describes, is basically broadcasting the data. So from one source, I'm broadcasting it to as many destinations as I want. So in this case, I have a SQL Server destination, Access database destination, a flat file destination, Excel spreadsheet destination, and a raw file destination. Many of you might be familiar with raw file, and it's basically a cache, a copy of what's in the cache, all the cache columns from SQL Server. So you can have whatever is in the memory space at that moment into a file. This is very important, and I like this very much. So I'm just going to execute this. And you'll see that my 5,940 rows will be broadcasted to all my different destinations. And this will be very useful, for example, if you want to keep like a flat file for auditing or logging and still insert the data in your data source destination. you can also, for example, if different business units want data in an Access database and some other business units want it as an Excel spreadsheet, you can accomplish all in one package in here. So that's basically what a one source to many destinations using that UNO is all about. In my third set of examples, I'm going to show you the merge join, and UNO. Again, in this one, I have purposely created a package that I know will fail, and this will be to exemplify something particular about the merge statement. So next, I'm going to, whoops, okay, I fixed it. All right, it should have caused an error, and the error would have been because of this. Let me do it false. So let me execute it. So this will be the error that should have been shown. So there's an error, and you'll see that merge with a red circle with a white X. And it will give you an error immediately because it's sensing that the merge input one must be sorted. So one of the requirements of using merge is that your source has to be sorted. Now, if you take a look at the source, both of them have an order by statement. So in essence, your data source is sorted. So why is merge statement complaining about not being sorted? So the reason is because the merge task, the merge transformation, it's reading the metadata of your data flow, and it's not particularly interested in looking at what's the SQL syntax, SQL command that you're using. So again, merge statement does not care about how your SQL command is constructed, but it will look at the metadata of these containers. So when I talk about metadata, if you go to Advanced Editor, and we go to Input Output Properties, it's looking at this property, the isSorted property. By default, isSorted is set to false. And if you see your output columns, all your output columns have a sort key position of 0. So there's no sorting key. So in order to fix that, what you need to do is change isSorted to true and define what are your sort keys. So in this case, sales order ID will be my sort key. Once I fix that, merge statement doesn't complain and everything runs properly. So the same I did on my left statement, I did it here. You have to go to right click, show Advanced Editor. For the source output, isSorted set to true, and you have to set one column, at least one column as your sort key position, different than 0. So it should be 1, 2, 3, 4. So that's basically how you do a merge statement. Now, there's also another way of doing a merge statement. This is the one that I showed you, and basically this technique is ordering your data from your select statement and modifying your metadata and specifying that isSorted is true and that your output column one of your columns is your sort key. So that is the preferred way of doing it. Now the other way you can do it is don't sort the data and just sort it inline as your data flow in your data flow by using the sort transformation, which you'll find here, right? Now you can do it this way, but sorting is very expensive. It takes a lot of resources, and essentially will make your package slower. If you run this, you may not see it because it's a small data set, but this will complete a lot faster than this inline sorting. Oh, we need to enable this. So you didn't see it, but this one will finish a lot faster than this one. So imagine if you have millions of rows sorting, this sort will take a sweet time. So try to avoid doing inline sorting. So that's merge. Now you have another one which is similar, but it's not the same, which is merge join. So merge join is basically allowing you to make inner, left, and full outer joins. You define the join table, a join column, sorry, in this case it's the sales order ID, and then you select the different columns you want to bring in from your two statements. So in this case, I'm doing an inner join, and it's going to grab 5,140 rows from each side and join it into a single destination. So that's very simple. Again, inner join, left outer join, and full outer join. Those are the three options available. My other example here is many sources to one destination. And this is very similar to the other ones, but in this case I have several sources, my Excel source, Access database, and raw file. I'm going to do a data conversion because SSIS, the SSIS driver for each one of these detects or may detect different data types. So in this case from Excel, it detects all of them as strings. From Access, it detects some as integers and some as dB timestamp and others are numeric or decimal. And from a raw file source, it detects everything as I had it on my cache, my memory at that point in time. So I just want to convert it so that all of them are of the same data type when I export to my destination. So once I have all my data cleaned and transformed and converted as I wanted to, I'm going to do a union all. So basically bring all the columns or the columns that I can union by. I'm going to derive a column, which is just a loaded by example, which is a column that I created to make sure that the data that's in my destination table was successfully loaded by my package. And then it will go to my destination. So 5,940 rows, 63,000, another 5,940 rows, all of them combined into my single destination. Since I knew I had duplicates, then on my destination, I chose ignore failure. So I know that exactly 5,940 rows will be in my destination, and just ignore those duplicates and ignore errors because of that. So that's an example why, when you know your data, you know you can ignore errors. Now my last example is a package that has many sources to many destinations. So again, I have Excel, Access, and a raw file, put them all together, and broadcast them into a flat file into a SQL Server database. In between, I have again this derived column, which is our example, loaded by example number here, just to know that I have my data from my current example. So if I execute this package, so I have all these rows coming in, put them in all together, and broadcast them into a flat file and into a database destination. Again, because I know there will be duplicates, I chose to ignore failure here. And if I go to my sample, I should have all that data in. I didn't make it. Okay. So that's just an example of many sources to many destinations, right? The flexibility of SSIS, extracting from one or many sources and exporting to one or many destinations. That's the end of my first example. How am I doing on time, team?
Looks like we have about 7 minutes till top of the hour. Do you have a lot more demo to do?
Just a couple of them.
Okay.
I'll run through them pretty quick,
All
like
right.
3 minutes.
That's fine. Take
So
your
the other
time.
example I have here, okay. So the other example I have here are aggregations and derived columns in a conditional split. So in this case, I have a source, which is my production.work order, and it contains all these columns, including scrap reason ID that I explained at the beginning. And I have a lookup, and this lookup will actually just connect to another database, could be at the same database, but it could connect to another table, and look up the value of the scrap reason description or scrap reason name. So if you see that mapping here, I'm looking up or doing like a left inner join of scrap reason ID on my source table and scrap reason ID on my lookup table. And when there's a match, it will bring my scrap reason name, which I alias as scrap reason description. But that's a lookup. It's like an inner join or left inner join. From this lookup, I have two options. I can have a match output. So if I find matches, all those rows will go this way. And if I have no matches, it will go this way. So if you understood that that production.work order table, and so the data that's in there, it's basically each work order and the different product IDs in each work order, and how many of them were scrapped and how many of them were not scrapped, right? So I'm interested in figuring out those who were scrapped, but also want to find out which of those were not scrapped. So I'm sending those here. So from my conditional split on my scrap products, I have that if scrap reason ID equals 1 and 10, I will categorize them as a single, not as ordered issues, scrap reason description. If I have scrap reason ID 4, 5, and 6, drill issues, 2, 8, and 9, paint processes, 3, 7, and greater than 10, parts issues. Anything else that doesn't fall in between here will be considered other issues, right? If you see here, this is a condition written in the SSIS expression language syntax. You see that this is an equality. If you only have one, you'll be doing an assignment. If you want to do an equality, then you have to do double equal. And that's very important to know because most people have that issue when they start using the SSIS expression language. So if it falls in this scrap reason IDs, it will be categorized as this scrap reason category. So once I define those, I have 1, 2, 3, 4, and 5 possible outputs. And that's what you see here, 1, 2, 3, 4, 5 outputs. So this is the flow where all my rows that conform to the drill issues will go through, not as ordered, the paint process issues, parts issues, and other issues. So for example, if we take our rows that go through to our drill issues flow, I'm deriving a column here called the scrap reason description. And that scrap reason description will have a value of drill issues. The same here for not as ordered issues. That column will have a value of not as ordered. Paint, scrap reason description column, paint process issues, and so forth. So all the rows that go here will have an added column with the value of the scrap reason grouping that I define. For other issues, again, are just other issues. Now for my no match, meaning those products and work orders that had no scrap, what I'm doing here is I'm adding that same column as no scrap, and I'm deriving a column in which the scrap quantity is really my order quantity, because in this no scrap, I want to have how many were not scrap, right? So that's what I'm doing here. And then putting it all together through a union, and now I have an aggregate, which is another transformation you will find here. And that aggregate is works the same as a group by. So I choose my column that I want to group by. In this case, product ID and the scrap and the scrap reason. So these are my group bys. And then I want my scrap quantities aggregated as a sum of all the scrap quantity by these two group columns. So very similar as a group by in T-SQL, right? And then at the end, I'll have a SQL Server destination, which is another of the destinations we have here. The only caveat with this one is that this SQL Server destination needs to be an instance running on the same server that you're running this package. That's the only caveat about SQL Server destination. Most commonly, you will use an OLEDB destination, which is right here. But if your package is running on the same server as your destination SQL Server, you can use this. So I'm going to execute this package. So you'll see that we have 72,591 rows. 71,000 has no scrap. 729 had scrap, and then the corresponding through each category, putting it all together and aggregating down to 541 rows. So if we see our output, we have this big this table with this big list. So I'll bring this little pivot that I created. And in this pivot, it's basically a SQL statement with a pivot function in which for each product ID, I have how much drill issues, no scrap, not as ordered, paint process, part issues each product had. So this is just a quick way of validating the data. So for some products, there were no drill issues, there were no not as ordered issues, and no paint process issues, no parts issues. So like for example, this product ID, all of it had no scrap. So we had no scrap with this product ID. So there's just a quick way to view the results of the data and the intention of our data. So this can be used really nicely on a report. So that's that example. The last one of the last examples I want to use is the loops. So loops is basically you have two options: the for loop container and the for each for loop container and for each loop container. So the for loop container is basically in this example, I will check if files exist in a directory, and I'll perform a file system task. In this case, I'm going to move files from a file name to a destination folder. So if we go to my documents folder, I have a folder called processed, which these files. So right now process is empty, and I have several files in there which are CSV, and I have an audit file, and I'm going to delete the contents. So this is empty. So what I'm going to do is with this for each loop container, I'm going to move all these files into my processed folder, and I'm going to create an audit log for all the files I moved. So for that, what I'm doing here is creating a collection of files. So it's a file enumerator. I'm going to specify what folder to look into. What are the files that I'm looking for? In this case, anything that has a CSV extension. And I'm going to save the fully qualified name of each for the files as it loops through the files into a variable called user var file name. So this will the fully qualified will be the folder path plus the file name. If I do name extension, it's only the name of the file plus its extension. And name only will be only the name of the file without any extension. So fully qualified is full path plus the file name. And then I'm going to write everything into a little auditing script constructed in Visual Basic 2008, reading that var file name. And if we go to the edit script, all that I'm doing is concatenating my fully qualified file name plus a little text, which is file x moved at this time, and just returning a a message box and also writing that text to my audit file. So I'm going to run this. So it's giving me that message box. File 1 moved successfully. File 2 moved successfully. File 3, File 4, File 5. And then at the end, all the files have been completed. If I go back to my folder, I see that all files have been moved to my process folder. And if I go to my audit file, I see that a line has been added for each file with a specific time each file was moved. So that's a quick way of moving files using SSIS. If I run this again, you see that nothing happened in here, and I just get a confirmation that all files have been moved. And the reason is because it looks, this collection looks if there's anything in that path that has this file name, and if it doesn't find, then it will just skip it and go right to the next task. So you see here, nothing's there because everything was moved already. So that's that example. This example is just a quick, fun way to fun way to work with SSIS. In this case, I am looping through a table called my tweets table, and I have a couple of columns and tweet messages that I extracted from Twitter, and it's going to loop through that table and show me the concatenation of all those tweets. So in this case, Patrick can't read my poker face. He's a Lady Gaga fan. Go Jaguars. Tweeting while doing number 2. Uh-oh. And workshops sell faster than Justin Bieber's concerts. So that's just a fast way to look through a table, different columns, concatenating those values, and instead of exporting them to a message box, you can export them to a file or to a SQL Server destination. The other one, which is I call the Wheel of Fortune, will just loop through these files and give me a price. So if I execute this, it will loop through each one, and randomly will give me a price. So I just want $25,000. So this is just to show that it will loop through all the different tasks within for each for loop editor. And for that, I have defined a var loop variable, an evaluation expression. So it will only loop through 10 times, and each time it will add 1 to that loop variable. So similar to a while loop in T-SQL, right? And the last one, which I'll do in 2 minutes. This is a very simple way of learning SSIS expression language. Here I have a data source. I have several columns. One of the columns is the plant cost, and the other one is operation type. So if we see that table in our source, would be the product that work order routing. So I have a plant cost, and I have an operation type. Some of them are regular and some of them are nulls. So that's very useful because when we are bringing this data, I'm going to have some of these operation types nulls, right? So what we're going to do in this package really quick is just grab what's the actual hours. We're going to look for that location ID, what's the hourly rate, multiply this actual resource hours times the hourly rate, and come with an actual cost. So, and then we're going to find the variance between planned cost and actual cost. So the first thing, we're going to look up the name. It's very simple. Connection to our source database and connect to that product table. Look up the product ID and return the name. And I'm going to alias that as product name. Second thing is we'll do here is and the cost rate at that location. So a location could be like a machine position, a part in the processing of a product. So each station or each location has a cost rate, right? So I'm going to bring the location name and the cost rate associated with it. So with that, we have the main columns that we're going to use for our derived columns. And here we're going to use some SSIS expressions language. So first of all, hourly cost rate. So there's a business rule in my package that says that if the location ID is 45 and my product ID is 748, then it will be a flat cost rate of $10. If it's not 748 and location ID 45, then return the cost rate off of that cost rate table, location table. So again, we're going to override, essentially we're overriding the cost rate that's on that table with a flat $10 cost rate. And you see the SSIS expression. It's column equal with 2 equal, that's an assignment, to 45 and product ID equals 748. So this is an if statement. So look at it as this way. If, and there's a question mark here, if location ID equals 45 and product ID equals 748, then 10, else cost rate. So that's how the if statement looks. You can find the if statement here in like the conditional expression, how it is constructed, and what are the corresponding ands, ors, equals, unequal syntax in the SSIS expression. And you have a couple other built-in expressions that you can drag in and see how they should be constructed. So that's cost rate. So that's the hourly cost rate, right? So if it's not 748, product ID 748 and location ID, give me the actual cost rate value. If not, then give me that. If it is, then give me that $10 flat rate. So the actual cost will be cost rate times actual resource hours. So this is the number of hours that that product incurred. So I'm going to multiply that times the cost rate. But if it is product location ID 45 and product 748, override the whatever cost and actual resource hours by 10. So there's a flat rate of $10 that's going to be allocated for that location ID and that product, no matter how many hours. So there's a way of doing that. Variance cost will be the planned cost minus the result of this. So I'm just copying all this, which is my actual cost. So look at it as planned cost minus actual cost. Start date, in the source data, it's a date time. So here I am just transforming it to a date data type. So I want to get rid of the time, same as end date. And then start time, I am actually, I just want the time piece of the actual start date. And same for end time. I just want the time. So this is a way of doing some typecast. I mean some typecast. So I'm just dragging DT date in here to extract the date portion, and DB time to extract the time portion of those columns. And then in product name, I'm doing something, a little bit of an example here just to show how that string functions work. So we have the replace statement here, the replace function. So in this case, if I want to do a replace in my product name column, whenever I find mountain, I'm going to replace that with off-road mountain. And that's just to show how those string operations work in SSIS. And then I have another one, which is another column that I'm deriving called the operation type. So if the operation type is null, in this case, is null is different than your regular T-SQL, where in your T-SQL is null, you're actually will replace this value, if it is null, with another value. But in SSIS expression language, it is just a Boolean of verifying or checking if that will return true or false if this operation type column is null. So if this is null, then if it's true, then I will assign that object operation type value special as a special value. If not, if it's not null, then just give me back that operation type value. So these are just some examples of the SSIS expression language and some of the functions and operations you can do.
That's awesome. Jose, we are getting a little...
Once I do that, I'll just...
I'll just point this out. Jose, can you hear me okay?
Yep, I am done.
All right, we're getting that was a great session. We are getting a little bit long here. I just wanted to make sure that we had time for Q&A. And you have a few questions. Is now a good time to read them off to you? Let's see what we have. Thank you, everybody, for some patience.
Yes.
I hope. And also, by the way, just to let you know, Jose will be back on Thursday. And what's the Thursday session, Jose? You've got Jose. Can you hear me okay, or you might have hit mute?
Yes. So Thursday I will be doing a presentation on report. Let's see.
I think building.
Hello.
I've got it over here. I've got your back. I've got your back.
Hello?
Let's see. On Thursday, we've got building SSRS reports on your cube. So Jose will be back then if you want to join us, which is great. And all right, so let's see here. The first question goes back a long way here. This was just basically, does SQL Server 2008 R2 install on Windows 7? Quick question for you.
Yes.
The answer is yeah, it does. No problem. Okay. Let's see here. And this one goes out to Gary. Gary, this one goes back a little bit. We're going back towards the beginning of the session here, Jose. And Gary wanted to know, doesn't SSIS already use bulk copy to load database data into tables? Jose?
You use the bulk copy. Yeah, can you hear me?
Yeah, I can hear you now. I think we have an audio issue.
Can you hear me?
Yep, I hear you loud and clear.
Okay, sorry. So can you repeat the question?
Oh,
can you
yes.
repeat the question real quick?
Yes. Gary wanted to know, doesn't SSIS already use bulk copy to load database data into tables? All right. I think we're having an audio issue, and it may be easier for everybody if we just wrap up.
No, not necessarily. You have to specify.
Yeah, Jose, there's a long delay between my questions and your answers. And just it's been a long session, so maybe we'll get to the question and answers separately. For those of you who want to join or speak to Jose directly, I apologize for the audio communication this morning. We have to work with Citrix and find out what's going on with the voice over IP. But Jose, are you on BIDN.com?
Yes.
You are, okay. So what I'll do, Jose, is I'll get some of the questions from today's session to Jose. You can reach Jose on BIDN.com. I think if we were to go through these at this pace, where there's a long delay between question and answer, it would be problematic for most of us. So we're going to wrap up today's session. Thank you. If you have any questions, again, we'll be back on Thursday. We'll work out some of these issues on the audio, and we will see you then. Thank you, Jose, for a great session.
Yep, thank you.